Okay, so this next part's a little harder. Horizontal stretches and compressions. So it's kind of like what we did with shifts, where everything that seems to be going on with the horizontal is kind of the opposite of what you'd expect. So anything happening to the x value is the opposite of, in reality, what's going to be going on. So let g of x equal f of x or f of bx. You'll notice that b is inside of the parentheses there. It's inside of the parentheses. So then the graph of g is obtained by taking the graph of f and horizontally stretching it if 0 is less than b is less than 1. So in other words, b is small. We're talking like decimals like 0.5 or fractions like 1/7. And it's a horizontal compression if b is greater than 1. Starting off here, we got f of x equals x squared, so the same parabola that we were dealing with earlier, and g of x equals f of 3x. So our rule, and I'm going to do f of x in red again, so we'll do x comma y is going to transform into function g, and since we're dealing with horizontal, we're going to be switching the y coordinates, and the y coordinates are going to be 1/3 of each, or the x coordinates are going to be 1/3 of what they used to be. So it's the opposite of what's being done. Now the best way we can remember this is take the reciprocal. Now reciprocal, you're often reciprocal. There we go. You're often used to think about reciprocals with fractions. Well, 3 is not a fraction. Well, sure it is. It's 3/1. Take the reciprocal of whatever's being multiplied by x. So if it's 3x, the reciprocal of what you're going to see in the rule, what you're going to see in the rule is going to be the reciprocal of what you're doing. So f of x equals x squared. Sorry, doing that in red. X squared. We're going to use the same value as -2. When we plug that in, we get 4, -1, 1, 0, 0, 1, 1, 2, 4. We're going to use these a good amount, so they probably will start becoming second nature to you. Now for g of x, we're going to replace x with 3x here. So instead of x squared, it's going to be 3x squared. Now, using our rule, our y value is going to stay the same. It's still going to be 4, 1, 0, 1, and 4. The x values are going to become way, way smaller. We're going to multiply each of those x values by by 1/3. So -2 times 1/3 becomes -2/3. -1 times 1/3 is -1/3. 0 times 1/3 is 0. 1 times 1/3 is 1/3. And 2 times 1/3 is 2/3. So let's graph these and take a look at what this ends up looking like on our graph. So using the graph for f of x, we had a -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. So that same parabola that we drew earlier, and I'm going to label it as f of x. G of x is going to be way smaller to start. So we have -2/3. Now we're not going to be able to get that exactly, but -2/3, we're going to say is about this far over. -2/3, and we're going to go up to 4, so we're going to have a point right there. -1/3, and let me just zoom in. -1/3 1 is going to be right about there. 0, 0, 1/3 1, and 2/3 4. So this one's going to be a much, much, much narrower graph. It's 1/3 the width of the old graph.